Hello everyone, my name is Kirill. Today we're going to talk about data classes. But before we start the video, make sure to subscribe to the channel and give it a like. Also, be sure to check the description, take a look at my Telegram channel and subscribe to it as well. There's also the IT interviewer bot, and we have an Avito portal that can help you prepare for any interview. Go to the description and check out all the links there. You might find something interesting for yourself. Today we're going to talk about data classes. Why do we even need them? When we work with Python code, sometimes we need to write classes like these that store data and transform it using magic methods, dunder methods like rep for retrieving data. So in these cases, we often end up writing a lot of code that in the end will be rewritten over and over again in many projects. You're just making more work for yourself. Data classes eliminate this issue. With data classes, we have, so to speak, we write a template according to which we will invalidate our values. Data classes support type hints. They support type annotations as well. With this, we can flexibly configure what data types we can store there, set default values, and how we can transform them. So all of this is very convenient. With data classes, we can create immutable data classes, inherit from data classes, and extend them in all sorts of ways. We'll take a look at this now. But most importantly, actually, it's worth mentioning that data classes support type annotations. That's really cool. For those who don't know, there's also a library called Pydantic. It's actually somewhat similar to our data classes, but I think there will be a separate video about Pydantic. We'll talk about it there as well. Basically, we've seen that we would end up writing these kinds of classes from project to project just to store data or transform it somehow, but we don't need to do that. That's why we should use our data class. And now let's see what that will look like. Here's an example of what our data class will look like. We import our data class, we import the data class and use it as a decorator. By marking it as a decorator, we write our class as a data class for cards. Here we specify rank and suit. Here we can also use type annotations to indicate what kind of data will be stored. With data classes, we can directly transform our data as needed. So we write our card, we define the data class for the card. First, we have the suit, actually, the rank. Let's say rank 1. Okay, rank 1. Next, we have the suit itself, and then we use print the card. We look and see that our data class card has both rank and suit. If we want to change something, we write rank. We'll have the rank itself. We do it. We see that the rank itself has changed to 1. So we can also access this and work with it. If we want to override some methods, we can also write our magic methods here and work with them. Well, not magic methods, dunder methods. I call them magic methods because that's what they were called in PHP. And in general, in Java as well, I think they're also called magic methods or dunder methods, so to speak. If we weren't using a data class, we would have to write a class like this. Again, we write init self rank suit and then assign our data here. In case we need some behavior there, for example, if we do a print, we need to register or parse here and do a return in low. Data regular card, 1 and 1, let's say. Print. We see our hello. So here we can override exactly how things will be displayed when we treat the object as a string. In other words, just do a print. If we remove it, we'll see that something unclear appears here. With data classes, we can see that our fields are displayed directly. So when we print a data class, it shows our fields rank and sutan. This makes it quite convenient to work with. Also, if we need to, for example, extend our data class, we can easily add any field we want. For instance, a title. Let's add a title here. It will be a string. Then we'll add well. Let's just call it age for now. It will be a float. So that's a floating point type. And then we'll write, well, float actually, not float. It will probably be an int. In the case of, I don't know, something else, it could be a float. So our latitude and longitude would also be floats, right? Float. If we want, say, some kind of active field to check our Boolean, let's add that too. So we only assign these specific values. If we print it now, we'll see that we get an error again saying that unfortunately our fields are defined, but we aren't assigning any values. So as a result, they're just hanging there and nothing's happening. To avoid this, we can specify our default values. Here we'll have hello, h will be 10, here we'll have 0, 0, here, for example, we'll have 0, 10, and active will be true. If we print it now, we can see that our default values are being assigned and we no longer get any errors. We can also work with this. Again, in data classes, we have all the supported types, well, all the supported type annotations. We can easily specify them here and validate our data as well. We can also write our own methods of absolutely any format in data classes. For example, let's say we have a method called print data, just as an example. Here we will accept self, and we'll also accept some kind of prefix. And what will we return? We'll return a string which will be an F string consisting of self, title self, active. And let's say the prefix will be included here as well. So prefix, all right, our method has appeared here. We can also use our magic methods here absolutely freely. We write cut print data and pass the prefix here. That's the prefix itself. Well, this is more like a post, and that's how we do it. Let's make our print like this. We can see the prefix itself. We can also output, if we need some magic method, we can use that as well. For example, repo. So we use self. All right. And if we access our card, we'll see that we have hello and true. So we can also use our magic methods here absolutely freely. This is great. It's a convenient feature that allows us to store our data more properly and in a more structured way. With regular classes, we end up writing quite a lot of methods, including methods for validating values. Basically, we end up writing the same thing over and over again. With data classes, we specify our type annotations, which make it much more convenient to work with everything because we understand what data types are where, how to interact with them, and in general, why we need all this. In addition, data classes have many other features, such as replacement, by the way, for classes, which can be demonstrated in practice. There's something interesting there as well. It's a standard module in Python, and you can basically do similar things there too. It's a bit different. I think the difference is in mutability. But the idea is pretty much the same. In general, there are many alternatives to using classes, but these are still classes. Again, they work conveniently with these annotations, with the type that allows us to understand what is stored where and how in general. By the way, besides what we have here, this is a class we can, for example, write a parent data class. We write this data class and inherit from it. Here, for example, there will be a field called name, a string that will be the parent. Well, for example, it doesn't matter here, we can inherit from it. So let's do it like this. We see the rank, and let's have default values as well. And this is the class card, rank, card. We need to remove it so that all our fields are displayed. We look and see name, our title, and now our name has appeared. Yes. The first value that follows for us is our name. So we've set our name, and then we set our rank based on the principle that our values just expand. In other words, it will look like this when we simply add our name, our field here. So we just combine them with each other. And in case we need any kind of typing, for example, if you have some object called coord, which represents coordinates, and coordinates are both latitude and longitude. To create this kind of class, we write a data class, and we can actually nest classes within classes. We insert it here, so we add the coord class. And what do we have here? All right. Let's look at the coord here. Okay, we'll remove this here and leave this here. These are classes, so let's put our classes here. We can see that we can actually specify type annotations here as well. This is a class, and that's perfectly fine. We can see here that, again, our latitude and longitude remain, and we need our coord, that is. We have another class inside this class, which we can also access and display here. This is our class with coordinates, and we can do the same if we have a lot of different values. So for example, if we have an array of our coordinate classes, we can easily specify a list here. If we have a lot of values here, we specify a list, and we need to define it. So we need to import list from our module, and here we also need to define our field with the default factory value. We also import from this class. This is how we create the factory. We see that we have a default factory, and we set these values here. For example, we call it and see that we have a data class. So here we can easily do this. Let's do it. If we have multiple values, here we use our field in which we will specify our factory, that is how to be formed. Also, instead of this notation, we can use our field here to specify our default values, default 0, 0, and metadata. So regarding metadata, if we want to access this metadata, we refer to H. So we refer to H. Let's take a look. We see that we have our 0, 0. Actually, to get our data, we need to write field and import it from the classes. Next, we use our data class card. Now, let's see what will be displayed. We see our fields. For us, this is 0, 1, 2, 3. The third one, let's take a look. We see that we have our field and we can already access our metadata. Looking at the metadata, we see that the unit is AA. So we can also easily access this if, for example, we need to compare something. Well, usually when we write our regular classes for storing data, sometimes we even need to compare them to see which one is greater, which one is less, something like that. So to perform this kind of operation, what's the first thing we need to do? We need to specify the order parameter here, which will allow us to do this. All right, next we take our class. Let's say a data class. We take ours and probably create a second card. Card 1, card 2, card 1, well, card 1. And we compare them. Let's go here, card 1, let's say card 2. Let's see what gets output. What gets output is, well, it outputs true. So here it outputs true. If we remove our order, we get an error saying that we can't perform this kind of operation to compare them. We have this kind of order and we can see that we have it, but if we want to transform some of our fields, that is specify exactly what we will use for comparison, we need to use a method, for example, str, with which we can access our data through self and return our data, for example, h. And here, let's set it so that we have the second title here. All right. Hello. So we need h. Here it will be equal to 20. And here it will be equal to 15. So let's set it to 15. And here we return to h and see that here it's true. If we check again, it will be false. That is, our card 2 will be less than our card 1. This is also absolutely true. So to compare, we can use this kind of order true. Also, if we need to work with immutability, in other words, make sure our values don't change. Because again, we see that if our rank so card goes here, we see that we remove the order, remove it here. Let's leave it like this. We see that our data class is displayed with all well. Our rank itself has changed. To make our values immutable, we need to specify the parameter frozen, which should be set to true. We do this and see that we can't set anything because it tells us that all our fields are immutable. We're trying to change our rank and we get an error saying that unfortunately we can't change our rank because frozen is set to true in our data class. That's basically it in general. Regarding data classes, besides data classes, in the future, we'll also look at identic type annotations. So if you're interested in this kind of content, make sure to subscribe, like, and definitely tell your friends. And be sure to join the Telegram channel because all the latest and freshest information is always there. That's exactly where I'll be running polls about whether we should make a particular video or not. Thank you all.